Okay, so this is probably our last video that you will watch. Yay, your training's almost done. So we made up to this point where we've generated our calibration curve. And we talked about the purpose of the calibration curve. The cal curve is only for my standards. That is it. I do not plot the absorbances from my samples and make a cal curve. The cal curve is only for standards. That's all. So I've got this regression line equation, and I've gotten this r squared value, and this r squared value was close to 1, which is good. And now I need to figure out what to do with the data. Okay, well, what I like to do is I like Excel to do this information for me. I can do a calculator method, and that's okay. But I really like for Excel to start doing these things automatically. Because Excel is really just a fancy calculator. That's all that it is. So what I'm going to do is that I'm going to type in the equation into Excel. And it's very important that you put numbers in a cell on their own. Don't put any letters in there with them. So for instance, y equals can go together into a cell. And then I'll come over to the next one, and I'll type in 0.4844, but I don't want to put the x with it. I just want the number in there, and that's all. So in the next cell, I do x minus, and then in the next one, I'm going to type in what my regression line says, 0.0037. So again, just a number, and that is it. So this is my regression line. My r squared looks pretty good, and I need to use this regression line to solve for the concentration of my samples. Alright, so there's the concentration of my samples. So these are absorbance values from the machine. We saw these and we saw them get generated in a previous video. 3 different samples, 3 different absorbances. And I want to calculate the concentration of how much stuff there was in this sample, right? Okay, so the way that I do that is that if this is the absorbance for my sample, if I look at my regression line and my chart, we put absorbance on the y-axis, right? Here was my absorbance values for my standards. I plotted those using the y feature. Okay, so that means that the y in the equation represents absorbance. I mean, that makes sense, right? I've plotted absorbance in the y-axis. The graph was made. The y-axis was absorbance. So therefore, in the equation, the y represents absorbance. So what I'm going to do is that I'm going to take my absorbance, 0.055, and I'm going to plug that in for y equals 0.4844 x minus 0.0037. And you're going to make mathematicians happy because what you want to do is you're going to solve for x. Well, what does the x represent? Well, the x represents the x-axis. What does the x-axis represent? The x-axis represents what I plotted on the x-axis, and that's concentration. That's how we solve for the concentration of our samples. All right? Now, I can do this manually using a calculator. 0.055, I'm going to add 0.0037 to each side, hit enter, get a number. That's equal to 0.4844x, so I divide each side of the equation by 0.4844, and I solve for the x number. Or I can get Excel to do it automatically, and this is how I do it with Excel. I want Excel to do the calculation, so I start off all of my calculations with an equal sign. This is a trigger that makes Excel understand, oh, okay, I'm getting ready to do a calculation. They want me to become a calculator here. So equal allows it to understand that. Okay, so what I want is that I'm going to take the absorbance from A. 0.055. Now I've started off with a parentheses because it's very important that I tell Excel what to do in the exact same order of operations, right? Okay, so I'm going to click this cell, 0.055. And what happens is that it references to that cell for me. It doesn't type in 0.055 here, it types in B11 because that's what's in cell B11. Okay, so it says take the number that I put here, and then what will happen is that to solve this equation, I'm going to add 0.0037, right? You do the opposite of. So this is subtract 0.0037, so I'm going to add. So I'm going to type in the plus symbol here, and then I'm going to click in this number because that's the number that we need to add to it, right, when we solve this equation. And then I'm going to close up the parentheses. I'm going to tell Excel, do that first, please. Order of operations is very important. The order of how you solve this equation is very important. Get rid of all the neighbors first, and then focus in on that one number. And then after you take that, the next step of solving the equation was coming down here and solving for x, which means that we're going to have to divide by 0.4844, right? Okay, so up here, my cursor's still blinking in that cell. I've not clicked off of that cell yet. I'm going to click the divide button, which is the backslash, and then I can reference that number as well, 0.4844. And that will solve for x. And what will happen is that I will hit enter, and this gives me 0.121181. Well, we want to shorten that down a little bit, right? I mean, my ppms up here were given in 2 decimal places, so I'll shorten this down and I'll give this in 2 decimal places. Not really proper significant figures, but we'll at least kind of keep it consistent. All right, so then I do it for sample B. I do the same thing. I hit enter or equal, start off with my parentheses. I'm going to take the absorbance from my sample B. Solving the equation, I add 0.0037, close up the parentheses. I hit the divide feature on my keyboard, and then I'm going to divide by 0.4844. And I hit enter, and then I can shorten that down if I want. Go up here to the top, shorten down those decimals. There we go. And then I'll do the same thing for C. I can hit equal, parentheses, take my absorbance. I'm going to add that number, and then I'm going to divide by 0.4844, and then clean it up. Now there is a shorthanded feature that I can do here. I'm not going to tell you what that shorthanded feature is because this is just an intro, right? This is just getting comfortable with the Excel world. So this is my concentration. That's my concentration in ppm, or milligrams per liter, and this is all based on my calibration curve. And it kind of makes sense, right? We said 0.173 should be in between my 0.25 and my 0.5 numbers originally, and it was. 0.36 is the concentration there. We also said that that was the same thing for 0.130 absorbance. It should be between 0.25 to 0.5, and it is 0.28. And if I look at this absorbance, 0.055, well, that should be between 0 and 0.25, and it is as well. It's 0.12. So this allows me to solve for the unknown concentrations in the samples that are provided to me, which is really one of the jobs of an analyst, or one of the jobs of a laboratory technician, or entry-level chemist, or entry-level technician, depending on whether it's the chemical version or biotechnology version, industrial version, quality control, quality assurance version, doesn't matter. This is one of my jobs on a daily basis. So this is how we get Excel to do most of the work for us. This is how we generate a calibration curve, and this is how we solve for an unknown concentration as far as my samples are concerned. So very important, right? So this is what you're going to be doing in the laboratory practical. This is what you're going to be doing in the if you're part of the competition. For the competition event, you will be analyzing a series of standards, making a calibration curve, figuring out a linear regression line, and then you'll be analyzing a series of samples and solving for the sample concentration. And you're going to be judged or graded on how well your standard prep was and how close you are to the actual true value that we know what it should be. Okay? So if you've got any questions, you know how to contact me. My email address is tholbrook@cfcc.edu, and you're more than welcome to call my extension at 910-362-7168. And if you can't get a hold of me, you're also more than welcome to call or email Kim Buffkin, who is the co-principal investigator and laboratory technician of the project. And that's kbuffkin@cfcc.edu. And her phone number is 910-362-7288. So, you have the resources available now to you that you should be able to hit the ground running when you come into the lab and start talking about the UV-Vis instrument. I do want to keep you in mind, or I want you to keep in mind, that all of this information and all of these videos will show up on the test, right? Whether it's a test in class if you're a student of the program, or whether it's a test for the Chemtechathon competition that will award you points. These are the questions that will show up. So make sure that you go back and review the theory. Make sure that you go back and review data processing and analysis. Make sure that you go back and look at pieces and parts because they're all very important. Okay? So if you've got any questions, please let us know. We can come out to you. We can send students out to you if you need us to. And we'll make this process as uncomplicated and unstressful as possible. So, good luck to each of you, and we will see you soon.